we're going to talk about is a formula. And this is very important. It gets used a lot, and it gets used on tests in the final exam, and we do not give you the formula. You do have to know this on your own. What it lets us do is it lets us rewrite any log base that we want as any other log base that we want. Generally speaking, though, we want to rewrite logs as a log base 10, which means an LOG, or a log base E, meaning a natural log, an LN. The reason being is we like the log base 10 and the natural log is because those two have buttons on our calculator. Things like log base 3, log base 5, log base 2, log base a half, those don't have buttons on our calculator. But there is a log base 10 or an LOG on your calculator. There is a log base E and LN on your calculator as well. So the idea is if I want to rewrite, let's say, I'm going to make this up, a log base 3 of 5 and figure out what that value is using a calculator. I can't as is. You have to use this formula, which is called the change of base formula. This is super important, and make sure you have it memorized. What the change of base formula says, we'll use the first problem as an example here, is it says if you've got a log base, and we're using 9 here, it could be anything, it tells you that you can rewrite this as any log you want. You can rewrite it as either the log base 10, the LOG, or the natural log. It doesn't matter which. The reason why we want to use those two, though, are because they are on our calculator. So just to show you, I'm going to use the LOG, the log base 10 first. And what the formula says is we're going to break this into a division of 2 LOG logs. And what you're going to remember, the key part to remember, is that the base goes on the bottom. That's going to be your key. The base goes on the bottom. Well, the base on this first example is the 9, so we're going to stick that on the bottom. That means the other number, the 12, will go on top. So that tells me if I want to find log base 9 of 12, I'm just going to find the log base 10 of the 12 first on top and divide by the log of 9 on the bottom in my calculator. And let's see what you get. And when you type in your log base 10 of 12 divided by your log base 10 of 9 using the LOG button on your calculator, you'll get 1.13. And it looks like if you got to 3 decimal places, 1. Now, just to point this out, had you chosen to use LN instead of the LOG log, it would have given you the same answer. The only difference would be that you use the LN on the top and the bottom. You would still be using the base, the 9 on the bottom and the 12 on the top, and you will get the exact same answer. The 1.131. So it really does not matter. It's just which one you like better. So we got 1.131. Let's try one last one. Let's look at problem B. So for problem B, we have log base 1/2 of 3. So again, you can use LOG or natural log, it won't matter. So I'm going to go ahead and use LOG log on the top and the bottom. Again, whatever you use, you have to use the same on the top and the bottom. You can't mix and match, but you can use all log base 10 or all natural log. It doesn't matter. Okay, so which one goes on the bottom is the base. So the 1/2 will go on the bottom inside of that log, and then the 3 will go on the top. So when I type this into my calculator, I'm going to do log of 3 divided by log of 1/2. And let's see what we get. Well, we get a negative 1.58. It looks like 5 as our answer. And again, you'll get the same answer had you used LNs instead of log logs. So that's our final answer, negative 1.585. And you do not need a graphing calculator to do this. You just need a regular scientific calculator to do this.